Hello and welcome back to another video. So in this video, we're going to be solving a computer science paper for practical. This is 2021, October, November for one. So in the last video, we did solve for two. So today we did solve May, June. So today we're going to try to solve October, November. So let's get started. So first of all, obviously, I am going to go to my desktop where I've saved the files that are needed for this exam. So I'm going to go ahead and open the evidence document. So just like last time, I will be trying to provide the evidence document as a Google Drive file in the description. Next, let's get Visual Studio ready by opening the folder that contains our text files. So I'm going to select the folder and just open it. So there I can actually access the text file, which is pictures.txt. With that being said, let's go ahead and look at the first question. So a classroom, again, a class declaration can be used to declare a record, and if the programming language does not support arrays, list can be used. And a source file is required for question 2e. This is called pictures.txt. So make sure you have them all during the examination. Alright, so without further ado, let's start with the first question. Study the following pseudocode for a recursive function. So they've given us a pseudocode for a recursive function that calls itself unknown, okay, whatever. The operator div gives 13 div2, which is equivalent to 6. In Python, that's like a double slash. Write the program code to declare the function unknown. So this is a recursive function, and all we need to do is just convert the pseudocode into program code. So let's just go ahead. So it takes by value two integers, x and y, and returns an integer. Okay, so in Python, let's just go ahead and create a file, question1.py. Right? The question just asks us to name it as question1.py, so let's just go ahead and make that. So I'm going to zoom in slightly. So let's start with the first part of the program. So we need to put unknown according to the question, and it takes two integers, x and y, as a parameter. Then we want to say that if x less than y, so if x is less than y, then we want to go ahead and output x plus y. So we want to output x plus y, and we want to call the function again with this following parameter. So we want to just say return unknown, return unknown, and now we want to call it with x plus 1 and y multiplied by 2. So x plus 1 comma y. And this return result, which we don't know, which will be called recursively until we know the final result, is multiplied by 2. Alright? Else, else if x is equal to y, we just return 1. So we would say, and then else, so again, we have got a few else's, so we want to say elif in this case. So else if x is equal to y, then we just want to return 1. And finally, the last call can be made with else, which we want to do is, again, we want to print or output x plus y and return, this time with x minus 1 div 2. So return x minus 1 y, and this divided with 2, or div 2. Right? So this is the recursive function. So this is going to be the program code for our first function. So let's just copy this to the evidence.doc file. Alright, so there it is. Okay. So now let's look at this next part of the question. The next part of the question tells me the main program needs to run all three of the following function calls and output the result of each call. So these are the 3 times the call. For each of the 3 function calls, the main program needs to output the value of those 2 parameters, call the function with those 2 parameters, and return the values. First of all, output the value of the 2 parameters. So first 2 parameters are 10 and 15. So I want to say print 10 comma 15, or just write a suitable message. And then I want to print whatever unknown is coming to. So I want to say unknown, and the parameters are 10 comma 15. Next is both of them being 10. So print 10 comma 10, and I want to say print unknown 10 comma 10. And finally I want to say print 15, I'm sorry, 15 comma 10, and I also say print, we want to go ahead and do unknown, so in this case it's going to be unknown. I want to do over here is 15 and 10, I believe. What is it? 15, yeah, 15 and 10. So this should be the program code. Let's see if they've asked us to, yes, they have asked us to write the program code and copy this to the evidence document. So in this case, I'm just going to quickly copy this to my evidence document. All right. So now the question asks us take a screenshot of the output. So let's go ahead and go to Visual Studio and let's try to output this. Let's see what happens. Okay, so it looks like we have a issue with this square over here. So the div operator in this case is not working for this convention. So what I would like to do is fine. Let's go ahead and put this into just divided by 2. And since it's the div operator, this should be, oops, sorry. So this should be just int. Let's try the function now. Alright, so operands for tuple and unseparable operand for the type tuple and int. Okay, so let's take a look. So what I want to do is this. Let's try adding another bracket here for the final return, but that shouldn't be an issue because, I mean, come on, we were doing the exact same thing over here. Let's try again. Okay. So for 15 comma 10, we are having a specific issue. So let's remove these for a second. Let's try to look at the code and see what happened over here. So we've got x plus y, and then this, right? So there's printing x plus y, return. Oh my god, oh shit, I actually forgot to call unknown over here. Great. So this should be unknown, sorry. So this should be unknown. Okay, there you go. Nice and smooth, we got an output, which is 1015, and this is the output for 1015, okay. So this would be the screenshot for the output. So during the exam, if you get a huge screenshot like this, then it's totally fine. Just make it smaller, as small as possible. Right? So we need to make a change to the code. We made a change to part 1a, right? So what we want to do is now let's just copy this once again. And oh, I forgot this should be div. Let's still check it for a second. Yeah, with the div, it still works. Okay, we're getting a 0 in this case. What if we remove the div? Okay, so 0 point something. So I think the answer should be 0 in this case. Right, so you got 15 comma 10. So it doesn't, if we get 15 comma 10, it doesn't do that. So we print x minus 1, 14. We print, and we kind of keep dividing all these values, right? So just to make sure that the output is correct, let's try to kind of visualize this slightly. I'm just going to change the color to something different, not black. So we start off with 15 while it's still black. for this teal. We start off with 15 comma 10 in the first case, and we know that this is going to be less x is going to be x is not less than y, so it's going to go to the else condition where it outputs x plus y. So 15 plus 10, that's going to be or 25, and then it calls the function with 14 and 10, right? So 14 and 10. So 14 and 10. So 14 and 10, so we want to do 14 plus 10 once again. So 14 plus 10 is going to be 4, and so it's going to 24. Oops, sorry. 24. Okay, so we call the function again with 13 this time. So 13 plus, that's going to be 23. Then we get 22. We want to output 22. That's going to be with a 12. Then the function gets called with an 11. So that's a 21. And then the function gets called with a 10, where it's equal to x. So we return 1 in this case. But once we return 1, we need to call the recursive call. So 1 is going to be divided by 2, 1, 2, 3, 4. So 1 divided by 4 times, actually. So that should be giving me 0.25, which is then just approximated to 0. So I think our output is correct from my calculations, that this should be what's happening for the 10 output. So yeah, I think we're pretty good over here. So I'm just going to go ahead and update the code here. That's it. Okay. So we write the function unknown as an iterative or iterative, whatever you're trying to call it, iterative unknown. Okay. So now we need to change this to a iterative function. So for now, I'm just going to remove this print section. So def iterative unknown. So it takes the exact same parameters, x and y, according to the question. So first, what we want to do is we want to find out the base case. So the base case is going to be this case right here. So let's highlight it with the red, meaning that this is the base case. And with green, we have two recursive conditions. These two recursive conditions right here. So the green one, so these green ones will be in the loop, and this one is exit the loop. Okay, so we have to keep that in mind. So with that, we want to go ahead and start our recursive, our iterative solution from recursive. So what we want to do is, let's say we want to return 1 if, kind of all the, if x is equal to y. We want to return 1 in that case. All right, so and other than that, we want to go ahead and loop through that, right? So let's do it this way. So let's make a local variable result, which is equal to, let's say, 0, right? Let's say which is equal to 0. Okay, no, equal to 1. Why is equal to 1? Because you can see that no matter what input you give, eventually x will be equal to y, all right? And when x equals to y, we can see that always 1 is returned. And divide or multiply whatever the value is, it is done with that 1. So 2, because we want to return this unknown, okay? So the result of this into 2. But this function, how many times was this function called? In this case, if I'm talking about this case right here, how many times is this function called? This function is called 1, 2, 3, 4 times. So it's 1 divided by 4, right? In that case, it's 1 divided by 4. So if that's a recursive case, what do you want to go ahead and do is keep result 1 and return that outside of the loop. So if we say if x is equal to y, then we say we just return the result. Else, while x is not equal to y, that means that's when we're going to keep running the loop. And over here, let's first check if x is less than y. If that's so, then if it's less than, we want to update the value of x to x plus 1. And result should be updated accordingly. So result times 2. Because what is happening over here is this recursive call is placed in a stack, right? This recursive call right here is placed in a stack. And we don't know the answer to this recursive call just yet. But notice that when the stack unwinds, when the base case is reached, we'll always end up getting x plus 1. So all the recursive calls is basically just a 1 when the final case is reached. So we want to multiply 2 with this. So every time each recursive call is called in the stack, we would say that the answer to the recursive call is 1. So what I mean by that is, let's say first is x plus 1. So our first stack would contain the result of basically 14, 10. Then the next one is 14, 10, and then 13, 10. Then the next one is 14, 10. We already have 13, 10. And then we had 12, 10. Then we'll have 11, 10. And then finally 10, 10. Now once we come to 10, 10, the 10, 10 is equal to a 1. Right? So this result should be moved to the next one. So this is also 10, this is also 1, this is also 1, this is also 1, this is also 1. Finally, right? Because the answer for this is 1. So the answer for this is also going to be 1 because we were missing this. To get the answer of this, we need to call this function. So then we can come back to this and we know the result is 1. Right? So we know that the result for this recursive call right here is going to be 1. So 1 times 2. Fine. Then we go back to this. So this is a 2 once again, right? So this 1 then changes to a 2. Great. So then this is 2 times 2. So it's going to be 4. So this changes to 4. This changes to 4. And then we move on to this. And then this changes to 8. Oh, sorry. So I'm a little bit incorrect over here. So this should be 2 to the power of 1, 2, 4, 8. So this is 2 to the power of 4 being called 4 times. So this should be 2 to the power of 4, not just 4 over here. So that's 1 over 8, which is equivalent to 0.03125, I believe. So that's what the interpreter was giving us, and it's rounded up to 0. Sorry, so I made a mistake over there. So finally, 8. So 2 is called 1, 2, 3, 4. 4 times we're finally getting the final answer, which is from this one. So 2 to the power 4 is 8, right? So we want to keep updating the result in that case. So the result is going to be multiplied with 2 until kind of we reach to that point. All right. In this case, we're dividing. Like this was the condition for division actually. So I actually kind of messed up. So 1 over 8 in this case. So as we mentioned, the result is times 2, right? Which is we multiply with a 1. And if it's not that, then we want to say that else result should be divided by 2. So in that case, result div 2. And we also need to go ahead and reduce x in this case, right? Because over here, as you can see, this is taking the parameters of x minus 1. So x minus 1, right? So that's pretty much it. And we want to go ahead and return result out of the while loop. Return result in this case, if x is not equal to 1. All right. So with that being said, this should be the code for our iterative solution, where this is the base case, where directly 1 is returned. Or you could just say that we can also return results here. It's sort of up to you. Let's just call it 1 for now. Else, while this is not the case, we're going to be continuously running this result. So x plus 1. and we kind of keep going, right? So with that being said, unknown, okay. So the function needs to be called 3 times with the same parameters as in part B. So it's literally the same thing. So I should have just cut that code instead of completely deleting it, but it's totally fine. So print, the first call was 10 over 15, so 10 comma 15. Then we want to say print iterative unknown is 10 comma 15. Then print 10 comma 10 iterative unknown, and then we're going to say 10 comma 10 and 15 comma 10. So print iterative unknown is going to be 15 comma 10 in this case. So with that being said, oh oops, I did not update the evidence doc. So this is the iterative unknown code, and this is the output return code. All right, so let's just remove the italics and save the document. And it says to paste the screenshot. So let's try to see if we get a proper output. Okay, so we are just getting 32. So we want to go ahead and also print the results, which I totally forgot. So we want to say print x plus y in this case. And I also want to say print x plus y in this case. So again, made some changes to the code itself. All right, and now let's try to take the output. There you go, we're getting the same output. In the exam, you could also check your code if you like to be sure that if you're correct or not, is that if you're getting the same output or not. If not, what I recommend is just try and forge the output using the previous one. The reason is sometimes the examiner will just skim through the code and look at the output. And if you're getting the correct output, that means your logical the program code is also correct. So sometimes there might be a chance that you might just get the mark. So try not to leave anything blank. Okay, so let's move on to the next one. So we're going to go to question 2.py. Right, so let's go to question 2. Okay, so question 2 is now object-oriented programming. So let's go ahead and try to do a program during object-oriented programming. Program says dimensions of picture of with height and color of the frame. And then we've got description with height, frame, color. The constructor takes all 4 values of parameters and to the private attributes. So make sure you keep that in mind. Some people actually, like some students, will actually forget that they're private and just declare them as public. So constructor takes description of desired parameters and so the private attributes. So whatever will declare the class picture and its constructors. So with that being said, we are going to say class picture. So and then we want to put a constructor code, so def init self. So first of all, we want to take a description as parameter. Description p, then we've got width, height p, and a frame color parameter. And then we want to declare private methods. So in this case, description is description p, width is width p, height is height p, and self frame color is just frame color p. So this would be the program code for the first part of the program. All right. Okay, so moving on to the next part. Okay, so the four get methods, for example, there's a description of the thread. So we only write the four get methods over here. So, oh god. So def, let's look at the naming convention. So get dis self. So we just want to return self dot description. Then we want to say def get with self return with, then def get self dot height, and get, I think it's get color. Okay, so just get color, right? So get color self return frame color. So for the four get methods, let's just go ahead and copy the code and paste it in our Word document, save it with Control S, and move on to the next part of the question. So after the get methods, we want to set description, takes a new descriptions parameter and writes it to the value to the appropriate attribute. So we want to just set description. So def set description. So we want to let's just call this new description. So it then has to obviously definitely update description to new description. Right, so that's going to be the single set method. All right, and then that's it. So picture with 100 elements. So picture with 100 elements, 100 of them. So picture array is going to be outside of this class. Let's just close this class for a 9. Picture, okay, oh, it's going to be of type picture. So I declare an array with, so let's just call it picture data. All right, just name our array, and this should be picture. That's pretty much it with 50 elements. So, and does it say anything else? It doesn't. So basically, you could just copy this because again, make sure this is just for 50 elements, so you could just keep it 50, or you could just do it this way. Picture for x in range of 100. You could do that, but that is not necessary. But it's all up to you. So I'm just going to write the code this way, nice and simple. So first press Control I to remove the italics, paste it, and then just Control S. Alright, so next one is the text file pictures.txt, stores data for in the order descriptions. Okay, so description, height, width, and frame color. This is the exact order. That's the function, read data, opens the file, reads it, creates new object, writes the object to the array, raises an exception the file cannot be found, and counts and returns a picture in the array. So let's make a global variable, number of pictures, TURAS, number of pictures. In this case, the first one is going to be obviously 0. Then let's just say def read data, right? So read data and opens the file pictures.txt. So first we want to try to open it, to open like the pictures and stuff like that. Read data from the file. So let's first try file open. Oops. So the name of the file is pictures.txt. So let's select that. Pictures.txt. We want to open it for reading it. And then we want to extract the following data. Description with height. So description is going to be file.readLine. And use the strip function to remove the empty spaces because they're in a new line. Then the width, so we do the same command. So let's just copy this. Height, same thing, and color, same thing. Then we create a new object. So we call it, let's just call it picture object is picture, and then we put the following data. Description, width, height, and obviously the color. Basically the 4 parameters in the order: description, width, height, color. Right? Description, width, height, color. And then we want to append to the array. So picture data, append, and then picture object, just like that. And obviously inside this, then I just want to make it global picture data. That means we're passing it by reference so that the values are updated. Okay, and then this entire thing should be in a loop, right? So, okay, let's just first go ahead and keep the description part. There's a reason for that, because I want to do while description is not equal to an empty string. We want to go ahead and just do all these. Oops. There we go. And after we append it, what we're going to do is we're going to be taking the description from the file again, right? While that is happening. Does it tell me to return anything? The function, okay. Counts number of pictures. Okay, so counts the number of pictures in the array. The main function we need to access. Okay. Creates new counts and returns a number. Okay, so it returns the number of that. So number of pictures over here. So global picture data and number of pictures. So once a picture has been added, then what we want to do is go ahead and just say number of pictures plus equals 1. We cannot put it after description because then, or should we put it after description? So number of pictures. It's actually the same thing. You could put it before or after because the loop will terminate as soon as we get a description that is a blank string, right? And once that is done, it'll return number of pictures. And then except IO error, raise an exception the file cannot be found. Except IO error, you could just return file not found. Or you could just, let's say, return number of pictures in this case, but it's better that we just kind of print file not found. All right, so with that being said, after pictures, this is the first first part of the program. Remove the italics, and that's pretty much it. All right, so for the next part, the main program calls read data. So we need to just call read data. That's pretty much it. So just call read data. That's pretty much it. Let's change that. Okay, so now I want to see that if there's any issue with read data. So just run it with calling read data. That's it. So for now, we are seeing that there's no issues, no error messages. So I think read data is correct for most of the part for now. So let's move on to the next part. The next part of the question says that the main program needs to ask the user to input the requirements for a picture. The user will enter the color, the frame, the maximum width, the maximum height of the picture. So this is for the user. Now, obviously, first of all, this will return the number of pictures, right? So read data available pictures. So let's put this in a variable named available pictures. And then the program will then search the array for the put the picture description of the width, item, any of the user requirements. Just needs to meet in it. The program should allow the user to input the color in any case, which is silver or silver, and output the correct result. All right. So we need to amend the main program. Okay. So first we want to take the frame color input from the user. The requirement: the user will enter the color of the frames. This is the first of all the requirements. So let's just go and highlight that for the sake of making it easier. So frame color, then we've got maximum width, and then I've got a maximum height of the picture. So these things. So frame color is going to be input, and then I want to say frame width. So again, this should be an integer. Input, enter a frame width. Sorry. And then we've got input, enter the frame height. Once I've taken these three inputs, I want to go ahead and kind of compare it with it. So for x in range to the number of available pictures. So remember this available pictures, we're going to use this now. Because we could do it with 100, but again, we don't know if there's 100 data in that text file. You could open and count them, but like, come on, you don't have that much time in the exam. So if frame color dot lower, because we just want to kind of match with all of them. So then the global area is over here, picture data. Picture data. Then we've got X. So get color. I think that was the name of the method, right? Yeah, it was get color. If that is the case. Or if the height matches well, because the question, I think it says of any picture. Okay, yeah, there you go. Any picture that meets requirements. It could be any one of the things. So, or frame width is picture data dot get width, or frame height is picture data x dot get height. Then, if that's the case, then I want to go ahead and print all the user's requirements. So in this case, I'm going to be printing picture data x dot get color, print this, print, so instead of get width, get height. Right, so this should be doing the job if I'm not wrong, without any errors, hopefully. Okay, so now the question, I think, asks us to input black 100. So let's try calling the okay, fine. Black 100. Alright. Get color is returning something like this. Object add. These two are okay. So what's wrong? Oh, okay, so just get color. We need to put the brackets to make that a get method, right? So black 100. Let's see. Black 20, black 30. Okay, so it gives us all the required data. So the first output, so copy the frame screenshots. So we need 2 screenshots in this case. We can't just use the Visual Studio method for multiple calls. And silver 2525. So we want to go ahead and call it again, this time with silver 2525, and gives us much less options out there. So if I can make it smaller, obviously I can. Just try and make them the same height. There are 2 outputs. That's it. Right? Alright, hopefully I'm still recording. Yes, I'm still recording. So question number 3 is the last question of this paper. So question 3.5. Okay, so the last question is going to be the trickier question of this entire paper. So we've got a binary tree in terms of an array. So ordered binary tree stores integer data in ascending numerical order. Each row in the table represents a node on the tree. Okay. And the number 1 represents a null pointer. So the array is declared for 20 nodes. So 20 nodes, each has a left pointer, data, and the right pointer. Root pointer is pointing towards -1. Free pointer starts off with free node, actually. The free node starts with 0. Write program code to declare all of these 3. Right? So all of these 3. So let's go ahead and write the program code. First of all, array nodes. It's the binary tree itself. So in this case, array nodes is going to be starting off with a -1, because -1 in this case is null, meaning nothing. Then it has 3 columns, right? 3 columns. So in Python, if you have 3 columns, that's going to be times 3 for x in range. And we have got 20 nodes in the question, so we've got 20. Then root pointer is initialized to 1, and free node is initialized to 0. Root pointer, initially it is -1, meaning there's nothing in the root pointer. So that's the first part of the program. Let's go ahead, remove the italics, copy, save. Okay, now the procedure add node adds a new node to array nodes. take the array root pointer and free node as parameter, ask the user to enter the data and read this, then add the node to the pointer if the tree is empty. Otherwise, follow the pointers to the position of the data has to be found and store the data in the location of data pointers. Now, they've given you a pseudocode for the order insertion of the nodes. So notice that we've got by reference. This is something we need to keep in mind in Python, right? So by reference, by reference, by reference. So once we have something like this in Python, meaning this has to be passed as a global variable, or the global, it should be passed as global. That's it. When something in Python is by ref, because if you do it as a parameter, then the values would be only updated locally inside the procedure, but not to the entire binary tree outside of the procedure. So that's important that you keep in mind. Unless you're using like an object-oriented programming or a record data type, like using a class to make a data type out of it, then you could kind of take them as parameters and it won't affect, like it will be like kind of like taking them by reference. But other than that, anything that you're taking by reference and want to update globally throughout the entire program should be taken in as global. So our method is going to be def, and then we've got add node, and then global array nodes root pointer free node. All right, take them as global. Then we want to input, so we want to input node data. We want to go ahead and input, so input, but the values inside the array are integers, so let's also keep that in mind. Enter, so let's say enter the data. Enter the data with a tiny space, exactly how it's mentioned in the question. So if free node is less than or equal to 19, so if free node is less than or equal to 19, so array nodes, so array node, we're going to start off by adding that to the free node, and then we're going to be updating our pointers as required, is going to be -1, that means it's pointing towards nothing. The next one is empty, basically. Then free node 1 is going to be node data, and the right pointer is also going to point towards null, right? All right, then we want to check if the root pointer is -1 or not. So if I think that's also the, so over here, there you go. So if root pointer is equivalent to -1, then we want to update root pointer to 0. Basically, the root pointer is going to point towards the free node, which is basically the first one in the entire tree. Else, let's put a local variable placed and name it false, just like the question has done. Then current node is root pointer. So current node is equal to root pointer. And while not, that means while placed is equal to false, basically. So while not placed, if node data is less than array nodes node data 1. That means it's going to be going to the left side of the tree. Then we want to check if the node is free. So array nodes node data 0. That means if it's free or not. Then we're going to go what is we want to replace it to array nodes. Oh, sorry. So this is going to be, why am I doing node data? Current node. Current node. So why is it equal to root pointer? Because basically we're starting from the root pointer and checking all the nodes. So this node 0 is going to be pointing towards free node. Sorry, not free node. Why free node? Because that means this is where we've added the binary tree. And then we just want to point the pointers of each of the trees, that means the left pointer, right pointer, accordingly, right? So that's what we're just going to do. And if that is not free, that's when you're going to put else, according to the question, else. Current node basically is going to be changed to array nodes, current node, then that particular left pointer. Now, if it's not less than, we want to go to the right side of the tree. So we're going to do the exact same thing on the right side, right? So you're just going to copy this, paste it, but instead of 0 over here, we're going to do 2's, right? Because 2 is the right node. That's pretty much it. And I think that's also the question has done. There you go. So the question has done the exact same thing that we were thinking. And free node should be updated outside the while loop. So we just want to keep updating free node. So free node is plus equal to 1. And if that's also not the case, it means there's a total error. Oh, and it should be outside of this else as well, like completely outside of the while loop, and should be outside the while loop. Else, yeah, there we go. And finally, if free node is not less than 9, that means the tree is full because we want 20 elements in this tree. We just want to go ahead and print in the question, tree is full. Right, so that's, oh my god, that's the entire code for the addition of a node inside a binary tree. Okay, so next, let's see what the question has asked us to do. The procedure print all outputs, array nodes in the order just stored in the array. Each element is printed in a row. So left data, then the right pointer. So write the program code for print all. So def, the name is given as print all. Okay. So again, I want to keep these as global. So it says it outputs in order. So first we're going to go to the right side. But before that, let's just call that current pointer, just like last question. We're going to start from the root pointer. Right, so we're going to be starting from the root pointer. And we have around 20 data, right? 20 data in this. But we don't know how much data we're adding. But the free node indicates how much data is there in the binary tree. So let's go ahead and do for x in range free node. You could update all of them, like all of the data. Like if you just do 20 in this, it's going to print out all the data, which is going to include the negative ones. And the question specifically did not mention anything about outputting the main ones or anything. So I think we're good. We could even write 20 here, or we could just write free node. It's totally fine. So I'm going to go with 20 because it sounds a little bit more accurate since the question never mentioned as anything. So for print, then I just want to go ahead and print. Oops. So array nodes x 0, that's the left pointer. Put a space. Array nodes x 1. Put a space. And then finally array nodes. And since we're already inserting the data in an ordered fashion according to the previous question, there is nothing much that we can do on this part or this side of the question. So def print all. Let's paste that. So the main program should loop 10 times, each time calling procedure add node. And then it should call the procedure print all, because we want to go ahead and test it with these 10 data, following 10 data. So let's go ahead and do it. For I in range 10 times. So node input, let's just call it node input, doesn't matter. Then we've got input. Oh, so we don't need to go ahead and do that because I forgot. We already did it in add node. So just go ahead and call add node 10 times. That's it. Oh, what did I just do? Wow. So we're going to go for add node. That's pretty much it. 10 times. And after we've called it 10 times, we just want to go ahead and call print all. That's going to print all the nodes. So that's pretty much it. It's very small code. So that's what I like about coding in Python. It's really, really efficient, really small. So okay, 10, 5, 15, 8, okay. So now let's try to run it. Enter the data. Okay, so you got 10, 5. Okay, something went wrong. It's not ending from the loop. So while not place. Oh, we need to update placed to true once the data has been placed. Right, so placed is going to be equal to true. Did I follow the pseudocode? Like, did I forget? Oh, there we go. So see, placed is true. Placed should also be true in that case. So made some changes to add node. So going back to the Word file, let's try to run it now. So we've got starting with 10, 5. Okay, now it's working fine. So the question asks us 10, 5, 15. Then we've got 8, 12, 6, 20, 11, 9, 4. Okay, there you go. So the binary tree has updated all the values, and there you go. If you had given the values as kind of up to the end pointer, then the output would have been a little bit different. I mean, the free node, because it would only output till this 4, because the rest of them are not like that. The rest of them are empty, so we don't need to update that. But again, it's totally up to you. The question doesn't specify anything, so we don't need to worry about that. So let's go ahead and paste the output for it. Okay, so finally, let's look at the next one. So we don't want to call this again and again anymore, so let's just keep that. Okay, we do need to, I forgot, we do need to go ahead and call add node because, you know, the data has to be inside the node. So we need to call add node once again because it's next question. So recursive procedure in order traversal performs in order traversal on the tree held in array nodes. So the traversal method first visits the left node, then outputs a root node, then visits the right node. So if we take a look at a binary tree over here, the traversal function will go to the left nodes and output the left node values according to an ascending order. So let's say 10, 20, then 30. After that, it's going to go to the root node and output the root node value, and then output the right node values. So that's how a traversal function works, in order traversal specifically. So we want to write a def in order traversal, and we want to have the array, which is going to be the binary tree. So I'm going to call it tree, and I'm going to call this one root. Then I want to visit the left node. So if the root is not equal to -1, meaning that part, like that left node is not empty, we want to go ahead and return, that means call traversal again, because it's a recursive function. So in order, we want to call the same tree, obviously, but this time it's going to be the new left node. So tree root 0, because we want to go to the left side. Then we want to print the left node value. So print tree root 1. And then the traversal is going to call root is not equal to, okay, not just root. We want to see the arrays, if the array itself has, you know, kind of, so the tree, sorry. So we want to call tree root over here. That particular tree root And we want to see the left node is empty or not, so we have to put 0 in this case. And in this over here, we want to see if the right node is empty or not. So we gotta go ahead and put this. And if it is not empty, that's when we're going to be returning, make the recursive call in order tree. So that is the in order traversal. Right? Okay, so once we have written the in order traversal, let's finally go ahead and take, so we just want to call in order traversal. So in order, so the array is going to be array nodes, and the root is going to be basically the root pointer. Now, obviously, we have to go ahead and add all the data again into the array. So in this case, that's going to be 10, let's go back, 5, 15, 8, 12, 6, 20, 11, 9, 4. Okay, so we're just getting the output for root 1. Alright, so that is a little bit strange. Just getting 4 as the output. Print. So we want to go and print tree root 1. So we want to go ahead and print this. Alright, so that seems to be working fine as well. What's the issue here? So tree, array nodes. If that's the case. Okay, if we go ahead and remove the return function, what's going to happen? The return function is going to be going ahead and just output. So we want to go ahead and not return this time, because then it's going to be only calling this once. So yeah, because the stack is going to only store one of those values, and like the final value is going to be output, the final value from the stack. So if you just keep calling it and then go for the print area, it's going to print out every one of them. Just keep recalling it, right? Just keep recalling it. So we want to go for 10, 5, 15, once again, 8, 12, 6, 20, 11, 9, 4. There you go. So the reason why we're not using return in this case, the reason is basically that if we use return, the recursive calls are being put into a stack. And just like we saw in question 1, the final value, as we saw in question 1, the final value in this case was basically 1. Right? The final value was 1. And with that 1, we were going ahead and doing the return thingy for that one. So in the same manner, the final value, okay, which is going to be the final root, the final right node, which is going to be, in this case, as you can see, it was 4, right? So only the final value was actually called, returned, right? So it was only called once. So in this case, we don't need to use return. We just use in order, like we're just calling it again and again. That's pretty much it. Okay, that's pretty much what we want to do over here, and then kind of call the function. So with that being said, this should be our traversal output. So we're just going to take a screenshot of this much it with the traversal being output. And obviously we made changes to the traversal function. So let's just go ahead and copy this and paste it. All right, so that's pretty much it for this paper. Hope you could understand and relate. and I'll be catching you again with a new video soon. Peace.